Section 2.7, Modeling with Functions. 4 basic steps to setting up your word problem. First, express the model in words, then choose the variable, set up the model, and finally use the model. Our first example will model the volume of a box. A breakfast cereal company manufactures boxes to package their product. For aesthetic reasons, the box must have the following proportions. Its width must be 3 times its depth, and its height is 5 times its depth. Find a function that models the volume of the box in terms of depth. So we're going to start just with what we know. We know that volume equals depth times width times height. So then we know that width is 3 times its depth. So we'll call that 3d, 3 times depth. And the height is 5 times the depth, so 5d. And depth we'll just call d. And that equals volume. So we can simplify this. Volume equals 15 d to the third. Find the volume of the box if the depth is 1.5. So then our volume will equal 15 times 1.5 to the third. Which is 15 times 3.375, which is 50.625 inches cubed. For what depth is the volume 90? So now we're just going to set the volume equal to 90. Equals 15d to the third. And then solve for d. So first divide by 15. So we have d to the third equals 6. Cube root both sides, and we get d is the cube root of 6. Which is about 1.817 inches. And part D, for what depth is the volume greater than 60? So we want to know when the volume, which you can say is 15d to the third, is greater than 60. So now it's just an inequality. We need to solve that. Divide by 15. D to the third is greater than 4. So D is greater than the cube root of 4. So D is greater than 1.587. And that's inches. So first, to fence a garden, a gardener has 140 feet of fencing to fence a rectangular vegetable garden. Find the function that models the area of the garden she can fence. So we have two things that we're talking about. We're talking about perimeter and area. Since it's a rectangular garden, we have a length and a width. Our perimeter would be length plus width, or 2L plus 2W. And our area is length times width. So since there's 140 feet of fencing, that means that's the perimeter, that's what you can go around. So since these are both doubled, let's just look at half of that, 70. 70 feet has to go halfway around, so that has to be the length plus width. We can rewrite that. Since our next parts of the example talk about width, we want to solve for length so that width is left in the equation. So we want length equals 70 minus width. And we're going to model area, which is length times width. So area equals length times width. Length is 70 minus W. And the width we just continue to call W. So there's our function. Area is a function of width. For what range of widths is the area greater than 825 feet squared? So we want the area, which we can write as 70 minus W times W. And we want it to be greater than 825. If we distribute this W, we could do that up here too. That'd be 70W minus W squared. So we can rewrite that down here. 70W minus W squared. So to solve this, we want to get everything on one side. So let's move the W squared to the right so it becomes positive. Minus 70W plus 825. So we can solve this by factoring. What multiplies to be 825 and adds to be negative 70 would be 15 and 55. So W minus 15, W minus 55. And solving that, we get that the width needs to be between 15 and 55. And that would be in feet. It's between 15 feet and 55 feet. Part C, can she fence a garden with an area of 1,250 square feet? So since it's just a yes or no question, we just need to find out what the maximum garden area will be. And since this is a quadratic, we just need to find the vertex. So we'll do negative b over 2a. B is 70. A is negative 1. So the maximum area happens when the width is 35. If you plug in 35, you get 2450 minus 1225, which is 1225. Since that's less than 1250, no would be the answer. And by doing that, we just found the largest area she could fence would be when she has a width of 35. And since the L was 70 minus W, the length would be 70 minus 35, which is also 35.